waves and the speed of the waves in the mainly we have to discuss about these waves in the sound waves, right? Here wave is nothing but a disturbance caused. Here if we take some water and throw a pebble in the water, then the disturbance caused in the water. Here for example, if we throw or if we drop a stone in a water, then we'll get the ripples in the water. That ripples travel from one place to another place. That means one point to another place. Here waves produced by the, for example, here if we drop a stone in the water, then the waves are the ripples produced in a water, and for example we drop the stone at this place, then the ripples produced and these ripples travel from one point to another point. Here in these waves the water as a whole does not travel, only this disturbance is traveling from one point to another point. This is called a wave. Wave is nothing but the disturbance caused, and in this the only disturbance is traveling from one point to another point. This is the waves. Here for example, if we take and there are three different types of waves we have. One is a mechanical wave, and electromagnetic wave, and matter wave. We have three different types of waves: mechanical waves, electromagnetic waves, and matter waves. Here mechanical waves, for traveling this mechanical waves, we should these waves will require a medium. Compulsorily for traveling this mechanical waves, a medium is required. A material medium is required to travel the waves from one point to another point. Generally in these mechanical waves, again we have two types of mechanical waves: transverse waves and longitudinal waves. Here in these mechanical waves, for example sound waves, seismic waves, these are the examples for the mechanical waves. For traveling these mechanical waves, compulsorily the material medium is required. In that material medium, for example, if the sound is traveling in a air, then the particles of the air moves from that means the particles of the waves oscillates from one point to another point. These oscillations carries the information. These oscillations carries the information, that is energy and momentum, like that. Here in the mechanical waves, mainly the air particles oscillates from its mean position, and because of these oscillations they carries the energy and momentum, that is the information from one point to another point. These are the mechanical waves. And coming to electromagnetic waves. Here electromagnetic waves, for traveling these electromagnetic waves there should be no medium required. Here example light waves, example mainly light waves. Here electromagnetic waves, there is no medium required, and they can travel in vacuum also. Electromagnetic waves. Example communication. Here for example, if we take signals, for example from the cell phone, the signals traveling in the air medium, and again these signals travel to the receiver, and these signals transmitted by the transmitter, and when the receiver is there, that receiver receives the signals, and these electromagnetic waves travels in a vacuum. There is no medium required, and the speed of these electromagnetic waves is equal to the speed of the light in the vacuum, that is nearly 3 into 10 to the power of 8 meter per second. Here simply the electromagnetic waves, for traveling this there is no medium required and they can travel in vacuum also, that is 3 into 10 to the power of 8 meter per second. Next to matter waves. Here matter waves are nothing but the fundamental particles, or the fundamental particles are atoms or molecules. Here simply electrons, protons, neutrons, atoms or molecules. Traveling of these electrons, protons, neutrons, atoms are in the form of waves, and these are called matter waves. The traveling of electrons, protons, neutrons, atoms, like fundamental particles, traveling is in the form of matter waves. Here these matter waves also have many applications. Simply, for example, if you take a electron, we have microscope. This is the application we have, that is electron microscope. These are the different waves we have, and in this class we have to discuss about mainly mechanical waves, that is sound waves we will discuss. Here waves means simply it is nothing but the disturbance caused, and when the wave is traveling from one point to another point, here only the disturbance is traveling, only disturbance is traveling, there is no, the total wave is not traveling. Here mainly mechanical waves, electromagnetic waves and matter waves we have, and in that mechanical waves compulsorily there is a material medium is required. Electromagnetic waves, this can travel in vacuum also, and matter waves, this electrons, protons, neutrons, atoms, like very fundamental particles, travels in the form of matter waves. And we have applications, many applications, that is electron microscope. Here for example, if we take a train, the train is at a stationary on platform. Here when the train is at a stationary in the platform, then the train, when the train starts, when it starts, then the engine is attached to the bogie. Here the engine is attached to the bogie, and the next bogie is attached to the next, like that. Here the bogies are attached with the train's engine. Now when the train is moving, here these bogies are connected with the engine like a spring system. Here when the engine is started, then the spring system causes the movement in the next bogie, like that. Here as a whole train is not moving, only the components of the elements of the train is moving, like a same wave. Here the total wave is not moving, only the disturbance is moving from one point to another point, like that. Here also if we take the movement of the train, the bogies attached with the engine of the train is traveling as not a whole, only the elements of the train or the components of the train only moving. Like for example, if we take here I am taking a spring system. Here if we pull this spring and left, then this spring makes oscillations. Here when this spring makes oscillations, then the disturbance in the springs, that is that makes oscillations then from the mean position. And here the total this spring as a whole does not move, only the component of the spring is moving. First this component is moving, and next this component is moving, and next this component is moving, like that. The components of the spring is moving and from one place to another place. This is the explanation for this waves. Now we are going to discuss transverse waves and longitudinal waves. Here there are the mechanical waves are two types of waves, transverse waves and longitudinal waves. In that, transverse waves, mainly transverse waves. Here in the transverse waves, the components are the particles of the medium. When these transverse waves are traveling, the particles of the medium are exciting perpendicular to the wave propagation. When the wave is traveling, the particles of the wave are traveling in the perpendicular direction. These are called transverse waves. For example, if the wave is moving along this direction, then the particles of the wave, the particles in the medium traveling in the perpendicular direction. These are the transverse waves. Example, light waves and electromagnetic waves, these are the transverse waves. When a wave is traveling, then the particles of the medium traveling perpendicular to the wave propagation. This is called transverse waves. And next, longitudinal waves. Here, if we take this longitudinal waves, and in this longitudinal waves, when the wave is traveling in a medium, then the particles of the medium traveling along the same direction of the wave. That is called longitudinal waves. In the longitudinal waves, when a wave is traveling in a medium, then the particles of the wave traveling along with the wave, that is along the same direction of the wave, they are called longitudinal waves. Here, for example, for explanation of this, I am taking here a string. I am taking the string is attached with the support. Then here, if we take this string and simply I am giving some push in the string. Here just we are moving this string, then the pulses produced in the string. Here these pulses traveling in the string